In this video, we'll show how to evaluate a function that is given implicitly using an integral notation. And first, let's try and identify the problem. We have an equation, x times cosine of pi x equals to integral from 0 to x cubed f of t dt. We don't know what the function is, and as it turns out, we don't need to know what the function is to be able to evaluate it at 8. And also notice that the function that we're trying to evaluate is sitting inside of the integral. And the opposite process of integration is differentiation. So we can use this fact and the idea of implicit differentiation. We can try to extract the f function by differentiating both sides with respect to x. So can we do that? Yes, as long as I do the same thing to both sides of the equation, that would be okay. And differentiating the left hand side with respect to x, it's a simple application of the product rule. Here we have derivative of x times cosine of pi x plus x times derivative of cosine of pi x, which is negative sine pi x, times derivative of pi x, which is pi. On the right hand side, we have an integral function, and to integrate it, to differentiate it with respect to x, we have to use the Fundamental Theorem of Calculus. And since we have x cubed in the upper limit, we have to use the combination of the Fundamental Theorem of Calculus and the chain rule. So let me remind you what that looks like. If I'm interested in differentiating a function, define like this with respect to x, then by using the Fundamental Theorem of Calculus, I get this. But since I have g of x instead of x, I would also have to use the chain rule and multiply everything by derivative of g. So that means differentiating the right hand side of my equation will give me the following result. I'm going to have f of x cubed, but because I have x cubed instead of x, I would also have to multiply everything by derivative of x cubed, which is 3x squared. And by differentiating both sides, I created a new equation, and now I can use this equation to evaluate f at 8. And also notice that in order for me to have f of 8, x must be set equal to 2. So set x equal to 2, and as a result we have cosine of 2 pi plus, or rather minus 2 sine, and actually I can move that pi to the front, 2 pi sine of 2 pi, and all that is equal to f 2 cubed times 3 times 2 squared. And sine of 2 pi equals to 0, cosine of 2 pi is equal to 1. So on the left hand side I have 1, on the right hand side I have f of 8 times 12. So dividing both sides by 12, isolates f of 8 on one side, and as a result I have f of 8 being equal to 1/12.